This video will walk us through example number 10 in our exploration of graphing square root functions. And what we're going to do here is we're going to get a little bit more complicated. We have a shift down 5. We can see that from this k value here of -5. But we also have a vertical stretch and a reflection over the x-axis. So I've graphed the parent square root function. I've graphed my ordered pairs 0, 0, 1, 1, 4, 2, and 9, 3. And what I'm going to do is I'm just going to follow the order of operations of this function in order to transform my parent square root function into the one that is listed here. So let's start with the point 0, 0. My y value is 0. Order of operations says I need to multiply that times -2 and then subtract 5. So 0 times -2 is 0. And then I subtract 5. And that gives me my first point at 0, -5. Here at 1, 1, I'm going to take my y value of 1 and multiply it times -2. That gives me -2. And then I'm going to subtract 5 from it. So I have a point at 1, -7. Notice how it seems to be opening down instead of up, as in the parent. We would expect that because of this negative coefficient. Now I'm going to take a look at this point at 4, 2. My y value is 2, and so I multiply that times -2, and I get -4. And then I subtract 5, and that gives me -9. So when x is 4, y is -9. And I'm going to be off the graph with this one, but let's go ahead and step through the logic. If I put 9 in for x, I get a 3. 3 times -2 is -6. And then I'm going to subtract 5 and get -11. So I would have a point at 9, -11, which would be about there. And if we take a look at this, what we'll notice is we did reflect, we stretched, and we also shifted down by 5 units. So our transformation is a vertical stretch of 2 units, a reflection over the x-axis, and we also shifted down 5. So, domain, we didn't shift left or right, so we still have our parent domain. But our range, we did shift up and down. Our range now has to reflect that k value of -5. Our x-intercept, we can tell by looking at the graph, it's not going to have one. And our y-intercept now is at 0, -5. So these are the answers to the questions that are below the graph. So if we make our generalization, explain the transformation of the parent graph y equals the square root of x to y equals a times the square root of x, we would say that it is a vertical stretch when a is greater than 1, and it's a vertical compression if a is in between 0 and 1. So let's write that like that. So you have a summary right here. And take a moment to explore the summary because it generalizes everything we've done so far. And it talks about vertical stretches or compressions. It says, explain the change to the parent graph. So if A is in between 0 and 1, we have a vertical compression. If the absolute value of A is greater than 1, we have a vertical stretch. H shifts us left and right, and we know when it's negative, it's going to go right, and when it's positive, it's going to go left. K shifts us up and down, and when K is positive, we go up, and when K is negative, we go down. Does this remind you of anything we have studied in a previous unit? I hope so.